So for what values of C are the following system inconsistent with a unique solution or with infinitely many solutions? So let me try this with the augmented matrix approach and then again using inverse matrix. So with augmented matrix approach, you would write down C1, 1, 2, 1C1, 2, and 1, 1C, 2. That's the augmented matrix, right? And then because you want to get a row echelon form, what you want to do is first multiply 1 over C to the first one. So 1 over C to the first row. That gives you 1 over C, and then 1 over C, 2 over C. The other ones will be the same. And then you're going to take the R2 minus row 2. You subtract the first one to get 0, right? And row 3 should also be replaced by row 3 minus row 1. So that you get with 1 over C, 1 over C, 2 over C. Then subtracting, you get 0, C minus 1 over C, and then 1 minus 1 over C, 2 minus 2 over C, 0, 1 minus 1 over C, C minus 1 over C, and then 2 minus 2 over C. Looks already complicated. Okay, and then the way you make row echelon form is you make 1, and using that 1 you make 0, 0 here, and then the next one is you make the next one as 1, and you make the other one 0. So if you think about the next step, what you have to do is you have to multiply R2 by 1 over C minus 1 over C, right? So that this cancels away. And that will make the next one as well. Now at this point it becomes this, I mean you could do it, it's not too bad, but you don't want to do it because it's ugly. So let me just hand wave from here, and then eventually if you work this out, you will get the final result as this one. Right? So this will be your RREF. And this final result seems to say that that system will have a unique solution, which is x equals to 2 over c plus 2, y equals to 2 over c plus 2, and z equals to, x1 equals to 2 over c plus 2, x2 equals to 2 over c plus 2, and x3 equals to 2 over c plus 2. That seems to be the answer. But then the question was not about finding the solution. It was saying that apparently for some value of c, this will have a unique solution, but for some value of c, this will become inconsistent, which means there's no solution at all. For some value of c, this will have infinitely many solutions. So if you did this work and you're staring at this final outcome, you would stop and think about for a minute, what does this mean? Well, first of all, there's something strange about this. It's strange because if c is negative 2, what becomes of this solution? The solution doesn't make any sense, right? So c equals to negative 2 doesn't seem to be okay. But it's not just that. If you go back and start to think about some other values of c, you see that some values are illegal. For example, this would be illegal if c is 0, right? What about this one if you divide by this? When would it be illegal? When c minus 1 over c will be 0, that will be illegal, right? So if you look at the case when c minus 1 over c is 0 to see what value of c would be illegal, move this 1 over c to the other side, multiply by c both sides, so that you get c squared equal to 1, which means c is
1.
or
-1.
minus 1. So it's plus or minus 1. Okay. And I didn't show you the full REF, but let's say you did it and you looked at every moment and see what's like the problematic value. You will make this following conclusion, that c equals to 0 will make that one problematic. Positive 1 will also make this one problematic. Negative 1 will make it problematic as well. And then negative 2 will make it problematic. But that's about it. Okay, so as long as c is not one of these values, all the REF will carry through, and you'll have a unique solution that's this one. Okay, so which means now you have to go back and see what happens when c is 0, when c is 1, when c is negative 1, and c is negative 2. And I forgot what it was. Oh, for definitely when c is 1, what do you get? If c is 1, you get 3 of these equations to be exactly the same, right? So if c is 1, they all say that the sum of the 3 unknowns is equal to 2. You only have one equation for 3 unknowns. What does that mean? You have infinitely many solutions. Okay? Yeah. And then for c equals to negative 2, if you do the REF, then do I have it here? Oh, I have it here. Okay. So okay. Since this is pretty straightforward, let me just tell you the results of the REF. So when c is equal to 0, it'll be like solving this would be solving this to REF form, right? If you solve this for REF, after doing many steps, you get 1, 1, 1, and 1, 1, 1. Okay, so what does this mean? Does this mean we have infinitely many solutions, or inconsistencies, or unique solution? This means, what does this mean? This means x1 is 1, x2 is 1, x3 is 1, right? So what does that mean? We have a unique solution. That's what it means, right? When c is negative 1, so it's like negative 1, 1, 1, 1, negative 1, 1, 1, 1, negative 1, 2, 2, 2. This 2 will also have your REF as 1, 1, 1, everything 0, and then you'll get 2, 2, 2. So what does that mean? Unique solution again. Okay. So those two cases, you'll have c equals to negative 1 and c equals to 0 will give you unique solutions. However, c equals to 1, as I noted, will have infinitely many solutions. So that leaves us with this last one, negative 2. Okay? So what happens if c is negative 2? So if it's negative 2, I calculated the REF, and it goes like negative 1, negative 1, 0, 0, 0, 1. That's your REF. Now let's write down what this means. This means you have 1 times x1 plus 0 times x2 plus negative 1 times x3 equals to 0. And then 0 times x1 plus negative 1 times x2 plus negative 1 times x3 equals to 0. And then it's 0, 0, 0. 0 times anything is 0. Equals to what? 1. So what does that mean? it's inconsistent because there's no way adding 3 zeros will give you 1. So this last line says this is inconsistent. Okay? Therefore, the final answer should be, so answer is that if C is equal to -2, the system is inconsistent. If C is equal to 1, it has infinitely many solutions. And then all other cases, all other C values will lead to unique solutions. Will give you unique solutions. So that's the answer. That's the full answer. Yes?
Would you give anything like this with us finding these solutions?
That will be very hard, right? So that's why I'm going to show you this second method. So having this on an exam and asking you to do it the REF, that's going to be too time consuming, so I can't have this on the exam. So instead, let's try to do this with matrix inverse form. So in a matrix form, the way you solve an equation like this is to write it in terms of AX equals to B, right? That's how you write down an equation where X is the column, X and B are columns of column vectors, and A is the coefficient matrix. So in this format, it's like C1, 1, 1C1, 1, 1C. That's the coefficient matrix on the left side, multiplied by the vector of unknowns, equals to 2, 2, 2. Is that okay? All right. Now, you would have a unique solution if this is invertible, right? If you can multiply the inverse to this one, and that's the solution. And since we're not really going after the solution, we're just figuring out when this will have a unique solution, all we care about is when this is invertible or not. Okay. What tells you whether a matrix is invertible or not?
If it has a
What? Determinant, yeah. If the determinant is 0, what do we know? It's not invertible. If it's not 0, what do we know? It is invertible. Good, good. So what we need to do is we have to calculate the determinant C11, 1C1, 11C. And let's do a row expansion. So C times C11C minus 1 times, if you choose the 1 and then cross out the row and the column containing it, then the minor matrix will be 1, 1, 1C. And then plus 1, if you cross these two out, it will be 1C, 1, 1. And then you're going to get C. AD minus BC gives you what? AD minus BC. C squared minus 1. Okay? Okay, how about this one? C minus 1. How about this one?
1 minus C.
1 minus C. Okay. Now I'm going to, instead of expanding, let's factor, because I see a C minus 1 as a common factor. Okay, so I'm going to factor this one as C minus 1 times C plus 1 minus 1 times C minus 1 as before. But this one, I want to switch this around at the cost of introducing minus. Now I like this because once you have it as form, then C minus 1 is a common factor, so I can factor that outside. If I factor the C minus 1 outside, then these things are left behind, right? So it's C times C plus 1. What's the widow here? Like the left behind ones. C minus 1 is gone, so you have minus 1. C minus 1 is gone, another minus 1. So that's going to be, now you expand, you get C squared plus C minus 2, C minus 1. And then you can further factor this as C plus 2, C minus 1 times C minus 1. Okay? And that tells us that as long as C, if C is negative 2 or C is 1, then the original matrix will, what? Not have an inverse. In that case, you're not going to have a unique solution. It will be either infinitely many solutions or the solution wouldn't exist. Okay? Yeah. So you would do this first and then treat those two cases separately. Okay? So then you can say, well, for the case C is equal to 1, that this turns into, so maybe I should write down the conclusion first. So if C is not negative 2 or 1, there will be a unique solution. On the other hand, if C is 1, then as I said before, you get x1 plus x2 equals to, x1 plus x2 plus x3 equals to 2, repeated 3 times. So what's that? In that case we have, if you have the same equation repeated many times, you have infinitely many solutions. Okay? And then, therefore, the only last remaining part will be C equals to negative 2. So let's not write down C equals to negative 2. So it's negative 2 x1 plus x2 plus x3 equals to 2. Negative x1 minus 2 x2 plus x3 equals to 2. And then x1 plus x2 minus 2x3 equals to 2. All right. So for this case, the way you can figure out whether this one has inconsistencies or infinitely many solutions would be, again, just do the RREF on this one, which these are numbers, so you can, if you have a calculator, you can easily plug in the numbers and do RREF and you can figure it out, right? So that will be one way to do it. Or another quick way, just for this case, you see the symmetry, so think about what happens if you add up everything. What do you get?
0.
0. What do you get?
0.
What do you get?
0.
What do you get?
0. 6.
Yeah, 2 plus 2 plus 2 is 6. So what does this mean?
Inconsistent.
Inconsistent. Yeah. It's impossible. Yeah. So in this case, there will be no solution. That's how I do it. Can we stop the video and record?